Okay, just going to talk a bit about quadratics today and recapping some of the stuff we've done in lessons. Remember that our general form of our quadratic looks like this: ax squared plus bx plus c. And remember that a, b, and c are all real numbers, and we call them the coefficients of this quadratic. So they're all these are coefficients. Okay, and remember what, our basic sort of quadratic, the graph that we get from it is called a parabola. And remember this point here we call the y-intercept. This line down the middle here, we call this is the axis of symmetry. And remember that was given by the formula y equals minus b over 2a. And this point here, right there, that was our vertex. And these here were our zeros. We haven't talked too much about them just as yet, so they're our zeros. Okay, so the first thing is our y-intercept. That's the place. So the y-intercept, that's the position, that's the spot where x equals 0. And if we substitute x equal to 0 into our general equation up the top, we see with this term here equaling 0 and that one there equaling 0, we end up that y must equal c. So we know that we plot these graphs on our Cartesian plane, and every point on a Cartesian plane is defined by a coordinate pair. So for the y-intercept, our point is going to be 0, c. Okay, so this is the x coordinate here, and that's the y coordinate here. So every point on this graph must have a x and y coordinate. So that's the y-intercept. The next bit we're going to look at will be our we're going to look at the axis of symmetry. Sorry, I just got to get my pen back. My axis of symmetry. And that occurs at x equals minus b over 2a. So the coefficients, remember b was the coefficient of x, a was the coefficient of x squared. And so from there we can work out our axis of symmetry. So our vertex, and remember if we draw these, our vertex is down here. Here's our vertex. And our axis of symmetry runs right down there because it's symmetrical. And I haven't drawn it that symmetrical, but you know how well I draw things. Is given by this. So what we do is we find out this value and we substitute this value of x into our y equals ax squared plus bx plus c. And that will give us our vertex down here, our x and y coordinates of our vertex. This was the x coordinate, is this value, and by substituting this down into here for x and working out y, we end up with that's our y coordinate of our vertex. Okay, let's have a look at a few examples. Go back here and get my pen. So if I had y equals 2x squared plus 3x minus 7, okay, so our y-intercept, the point is going to be 0 because that's when we go through the y-intercept. This point here has got, this is x equals 0 here, okay? So, and we read it off, it's just the value of c, and c here is minus 7. We just read that off from there. That's a negative 7. Okay, so our axis of sim, x equals minus b. Now, b here is 3, divided by 2 times a, and a here is 2. So that's going to equal minus 3 over 4. Okay, so there's our axis of symmetry. So we'll just go back and get rid of all of that. So we had our axis of symmetry was at x equals minus 3 over 4. And we just need to substitute that back into our equation. And remember, our equation was y equals 2x squared plus 3x minus 7. That's a 2 there. So I need to substitute there. So y equals 2 times minus 3 over 4 all squared plus 3 lots of minus 3 over 4 take 7, which equals 2 lots of, this one's going to give us 9 over 16. This squared, 9 squared is 3 squared is 9, 4 squared is 16, and the negative, any negative number squared gives us a positive number. This is 3 times minus 3 gives us minus 9 over 4 take 7. Now I'm just going to get all this in terms of, I'll put it under a common denominator of 16. So this is 18 over 16. Okay, minus, and once again, this is, I'm going to times both sides by 4 over 4. So this is minus 36 over 16. And minus 102 over 16. Okay, 7 is just, if you do the math, that's how it works out. And so we're going to get the y coordinate is 18 minus 36 minus 102, which is actually minus 130 over 16. So our vertex is at the point minus 3 over 4 minus 130 over 16. Okay, so that's how that one works. You can see the maths gets a little bit complicated, but you can put that in your calculator. There's no problem, and you'll find out. You should find out that all those sums work. Okay, a few more examples. We're just going to, it seems people had some problems working out the coefficients. So I'll just give a few examples of coefficients. So y equals minus 3 over 4x squared minus 2x. In this example, the coefficient of x squared is a, and that's going to be minus 3 on 4. And b, our coefficient of x is minus 2, and c is 0. Because we could just, a plus or minus a 0 here, and that's where we get our c from. Okay, just going back, try it again. Try another one. Y equals minus 10 plus x squared minus x. Okay, so a is the coefficient of x squared. There's our x squared, and of course there's a 1 in there implicitly. So a is 1. B is our coefficient of x. There's our x terms, and there's a minus 1 in there. And c equals minus 10. Okay, once you got those sorts of things worked out, it actually, you find it's not too hard. All right, going to leave it there and come back and we'll talk a little bit more zeros of quadratics.